I want to say a few words of thank you, first of all, to the conference staff who did an amazing work setting this up today, and to the amazing speakers of this morning. So, without further ado, a few words about me. My name is Nicolas Goutay. I'm French. I work at Theodo, a web consultancy. We're based both in Paris and London. I'm a full-stack developer, so I build JavaScript and Python web applications, and I'm really excited to be here on stage to talk to you about web performance. You can find me online on Twitter or GitHub at Fax. A quick story about my last year. So I've been working at Theodo for 3.5 years, something like that. And starting at the beginning of this year, I went on a mission to make all the applications we build at Theodo. So we build in parallel maybe 15 or we have 15 or 20 different projects to make them all really performant. So 1st of January I'm really eager to do that, and then 1st of January I'll start digging into web perf, and I found out it's really difficult. So this is what I had in mind when I started. Like the alien thing, web perf, is really, really difficult. But so I started real slow. Last February, we counted. We had 3 out of roughly 20 web apps that were considered performant, meaning they would load, they would be interactive in under 3 seconds. But I did some work. I worked with the team. I grasped some knowledge about it. And then the progression was quite interesting, because last June, up to 8 Theodo web apps were performance. And as of today, there are 12. So in the span of not really a year, the work that we did at Theodo regarding web performance was really interesting. And now what I want to talk to you about today is how we built a culture of web performance at Theodo to achieve such results. So the first thing I want to talk about is in the culture of web performance is to give structure to teams, to developers, etc., to work on performance of their projects. The second thing would be tooling. You need to make the best tools available to your team, and you also need to teach those tools to the teams. And the third part, the third pillar of the culture of performance at Theodo is knowledge. You need to have a knowledge of web performance to start working on it, to know what to optimize, where to look, etc. But you also need to share that knowledge to make sure that everybody on the team or teams is knowledgeable about web performance. So let's start with structure. At Theodo, we are using a lot of lean methodology. So I don't know if any of you are familiar with the lean manufacturing thing. So you may have heard of lean startup, though. So in manufacturing, lean is a systematic method to maximize customer value while minimizing waste. So it sounds bullshitty when said like that, but what's really interesting about it is that it helped propel Toyota, so the car manufacturer, from a really small company in the 40s, 50s, in the post-World War II Japan, to the #1 automaker in the world in the span of 50 years. And so lean started to manufacturing, so they had these plans with these huge assembly lines to work on cars, and they really worked hard on how to make that more efficient, how to fight waste. But though it traces back to manufacturing, it can be applied, the methodology, the philosophy behind it, to really any industry, and the one that we're interested in today is digital product crafting and web performance. So today I'm going to talk about 2 different aspects of lean that I used to work on web performance at Theodo. The first one is called the value stream. In lean, the value stream, it's a representation, it's basically a drawing of every value-added steps that your product go through to go from the raw materials, so what you receive in your factory, to the finished product. So if we take cars, you would have the part where you have the car body, then you have the wheels, then the windshield, then the seats, etc., etc. What's really interesting about this tool is that it helps you visualize and understand the whole process of what you're doing. And when you mapped it out, when you drew it, you can easily see waste and fight it. And so how does this apply to web performance? So what we try at Theodo was to write down and visualize all the steps for a website to go from the user interaction, so a click on your website on Google or submitting a form or whatever, to the website being interactive. So it looks a little bit like that. So you have 9 steps. It's broken down by chronological order. So first you would fetch the HTML, do some processing on it, and then you would fetch the assets. So we're building a lot of single-page apps using React or Vue, and so the bundle is an important phase of the assets, the JavaScript bundle, and then you do some data fetching from your microservices or whatever. And so we drew this one. So this is like the 4th or 5th iteration of the value stream, and we set out to define standard timings on every steps. So as we can see, we aim at less than 100 milliseconds to download the assets, or to less than a second to process the data from a data-intensive backend, etc. So once we have this this analysis tool, we can take a website and using the Google Chrome DevTools, we can go through it and measure every steps and really easily spot the ones that take too long, in which there is weight that we can fight. So this is an example on a Theodo website. We can see that there are 4 steps that are taking too long, and that the overall loading time is nearly 7 seconds. So it's way too big. And once we have this analysis, then we know exactly where to look and what to optimize. So here we can see that the bundle, the assets are taking too long to be fetched. So we may look at code splitting, or importing less heavy libraries. Or if we see on this step that the JS code, when receiving data from the backend, is taking a second and a half to parse the results, then we know we have to start at optimizing the algorithms that we use to parse the data. And so we use this analysis tool on many projects at Theodo, and it reached awesome results. So that's part of why we are now at 12, so like times 4 or 5 performant web apps. What are the advantages of identifying and mapping the value stream in web performance? First of all, it forces you to look at the whole process, not just front-end if you're a front-end person, or just back-end if you're a back-end person. It is an unbiased way to look at things. I know I'm more of a JavaScript guy, so when there's a problem, I tend to look into JavaScript directly, but sometimes that's not the case. The main problem isn't in JavaScript, it's in the backend. And so this tool really makes it plain simple where you have to look for performance gains. When we set standard times, one of the key benefits of that is that teams making analysis will seek help much sooner than before, because they can be KO on just a small step, let's say the asset downloading. And so when they see that part of the process is red, then they may come to me or to another performance expert at Theodo and say, yeah, we have this small step where we are taking too long, like 200 milliseconds too long. And since the problem is small, we can fix it really faster. Before that, I had project come and see me and say, yeah, my website takes 40 seconds to load. What do I do? And I'm like, oh, yeah, here we go. It will take month, and it did take month. So when you set standard times, you anticipate the problems much sooner. And then the value stream is a great format to communicate with stakeholders and get their buy-in. So I think it was Harry this morning telling that business people like spreadsheets. Well, guess what? Business people also like flow diagrams, so they really understand what's happening. And then when there's red spot on that diagram, they know instinctively something is wrong. So when we used this tool to communicate with stakeholders, they clearly saw what the problem was, and they were willing to put in work to optimize that. Oh, sorry. Second tool I want to talk about is called the Jidoka in Japanese. So the Jidoka philosophy is to try and catch the problems at their earliest. So in Toyota factories, when you have a defect, so I'm a worker on the factory and I set up windshields on car. And if, when I'm putting on a windshield, if I see a defect on the windshield, maybe it's cracked or something, what I do is I press a button and the whole line stops, so that I can have the time to see and to understand what happened, and it means that my supervisor will come and see me to try and help me fix the problem on this particular case, and also once and for all. When there's a problem on the assembly line, supervisors and managers are really trying to think on how can we prevent this problem from happening again. So this is called a Jidoka. And for developers, their environment is not an assembly line, but it's many things. It's the IDE, it's the web browser, it's the console, it's the CI environment, production environment, whatever. And so here are a few examples of Jidokas we set up in Theodo. So in the IDE, we use an extension called import cost, which will print right alongside your code the size of the libraries you're trying to import. So this is from a React project, and we can see that when I import some button from Material UI, which is a library to make nice UIs, I really have a huge bundle size here. And so the developer seeing this will pause and think, okay, do I really need this library? Can I do by hand? Can I use another one, etc.? In the command line, so there can be a problem when you're building single-page applications. Say you depend on a library, say Lodash version 3, because you do a lot of business with arrays and objects and such. And then you want to add in a new library, say Material UI, which depends on Lodash version 4. Well, if you don't do nothing, you will send your user both versions, meaning that you sent a duplicate library, and it's taking extra bytes and extra time for basically no gain. So this everything will be available on the slide. I will set up the link later on. But this is a really small script that runs every time we do yarn or yarn add or npm install or whatever. That will check that there are no duplicates libraries inside the bundle that we send our users. And then in the CI, so continuous integration, every time we push a pull request, a new feature, etc., we also have a routine that will look for the size of the website in the end. And we have a threshold. Here it's 500 kilobytes. And if the size of the website is over the threshold, then the tests break, and the developer has to look at it and see how come the size increased with my pull request. Why 500 kilobytes? And if you want to find the right threshold, I built a really simple performance budget calculator on spreadsheet. And so depending on the network speed of your user, so if you want to build an app that will be usable over 3G, and the number of seconds that you want them to wait at max, so all these are parameters, then you know on the left-hand side which package size you can afford. And so yeah, there'll be the link at the end as well if you want to play around with it. So now for the tooling, it's really important that you give out the best tools to your developers. And we saw a lot of tools actually today. So in the talks this morning, we saw web page test, we saw Lighthouse, etc. So what I wanted to focus on was tools that I discovered lately in my process of working on web performance, so that I didn't know when I started, and I wish I had known when I started. And let's start with Chrome DevTools. Chrome DevTools is an awesome resource. There's many things, and many of them are pretty hidden, which is weird because they do awesome things. So this one is the coverage. I don't know if you ever seen it. So there should be a video. Yeah. So the idea is that you send your whole JavaScript application and React and libraries and whatnot. And in Chrome, there's a really handy tool. So the coverage that works as the code coverage for your tests, say, but it computes the number of lines that the browser actually needed and went through in your application. So here on this website, we can see that nearly 44% of the bytes I sent the users were useless. So this will, and then we can have on the line per line basis at the top hand corner. So this is really helpful for detecting, do you send too much JavaScript to your client? Is there any dead code lying around or unused library, etc.? Then pane flashing. So it's another one that's quite hidden. So pane flashing will, when you're building single page application or any application really, you want to minimize the number of repaints that the browser does because it's CPU intensive or GPU intensive, and it may lead to Yankee UIs and lags and whatever. And so when you use pane flashing, you is the video on? Yeah. Now we go into the console, and you will see what exactly is the browser asked to repaint. And if you see something that shouldn't be repainted because it didn't change and shouldn't have changed, then you know something's up. So here, I'll just hover the top two cards, and I see that my browser repainted the bottom two, but it shouldn't have been. They didn't update visually. So I know something's cooking inside that. And to go further, when I know I have parts of my UI that update when they should not, one can use a really handy library called Why Did You Update? So I think it's React specific, but they may be an equivalent for Vue or Angular or something. The basic idea is that if React asks the browser for a repaint of a component, although the parameters you've given that component didn't change, which can happen if you don't pay attention to the way you're instantiating your components. Why Did You Update will display a handy warning in the dev console, and so the dev can be immediately warned that something went wrong somewhere, that there is a performance optimization that we can use. So after that, there's bundle size. So I demoed it really earlier it was the CI thing. So bundle size is a library that you can use to compute the bundle size of your website or of a library you're working on, or etc. So we saw earlier that we can set it up in the CI to have the exact info of how it went, and you can also have the integration with GitHub pull requests and GitLab pull request, I think. And so this, when you have your threshold using the performance budget calculator, you can just set it in bundle size. It's, I think, 4 or 5 lines of code. It's really easy to set up, and then you're good to go, and you know that you keep your bundle size in check at all times. And the last one, that may be my favorite. So this one isn't a library or a Chrome thing. It's a website called Phobia. So say in my project I need to handle a lot of dates and time. I may want to rely on a library to use it because it's difficult. It's really error-prone, so why not using a library? So I go on Phobia, and at the beginning I wanted to use moment, and I type moment, and I can see really easily how much it will add to the bundle size without even going in the IDE, etc. So 64 kilobytes gzipped, maybe a little bit big for what I really need. So I can Google the moment equivalents, etc. And I found another one called date functions, which has pretty much the same scope in its features and API. And then I type it on Phobia, and I can see that I divided by nearly 10 the size of the bundle. So it's a really handy tool, and it also has an option to, if you give Phobia the package.json of your project. So package.json is the file where you specify all the libraries you're using in your site. It will analyze it and tell you, okay, that library that you're using at that version weighs such and such, etc. So it's a really handy tool to fight waste and large payloads in JavaScript. And for knowledge, so I did learn a lot personally on in my works on web performance, but what I found out was that I alone was not able to fix all the problems of performance in 100+ developers team. So sharing that knowledge is really key in your organization. And so we set out to do multiple things to ease that sharing of knowledge. The first thing is that every week we have a 1-hour informal meeting related to all things web perf. So it's open, everybody can get in or not get in depending on their agenda. But it's a time where we can talk about the articles we read, about new libraries that we want to test, or do a feedback on some library we tested, or I do have a specific problem on my project right now, and can anybody help me, etc. And so it did create an atmosphere of emulation regarding web performance. Then I would also advise you to create a dedicated channel to web performance on your company's social network. So we're using Workplace. It's like the Facebook, but for companies. But on Slack, on WhatsApp, on Yammer, I don't know what you're using. Be your own community manager on it. You may want to post the links that you read and you found interesting. You may want to spark debates on it. But it will show everybody in the company that you care about it and that it's also interesting and it's fun. So if you manage the community of developers or business developers in your company that way, everybody will be keen on taking upon performance problems. And lastly, so we're big fans of visual management over at Theodo. And so I have this really huge whiteboard in the company in which I showcase every project that we were able to make performant. I write about what we are learning, what we already learned. We print some internal articles that we wrote on specific subject, etc. And so it really puts everybody in the company can come and see this whiteboard and the progress we are making, and see that we are really committed to web performance. And it really helps when you want to get business people on board on getting some time to work on web performance. You can just go to the whiteboard and show them, yeah, that's what we learned today. You can see this and this project that are similar to yours that went from, I don't know, 10 seconds or so to 2 seconds. And it really proves the impact of what you're doing. And so if you want to get started learning about web performance and implementing a culture of web performance in your company, I have 2 resources that I would highly recommend you. The first one is really new. It's called web.dev. It's Google released it, so it's a website. Google released it, I think it was 2 or 3 weeks ago, or maybe 1 month. So it's an online resource concerning all things web development. You have an online lighthouse audit. I think it was Katarina talked about it before lunch. You have lots of tutorials if you want to implement code splitting, if you want to know how to optimize your images, if you want to minify your CSS or your JavaScript, etc. You have lots of tutorial, and then they even implemented an online code IDE so that all the tutorials are actually interactive. And so it's really a nice way to learn about web performance. And then lastly, so that one is a free ebook called High Performance Browser Networking, HPBN. It's a step further, so we'll talk about how protocols really work and how the inner workings of the browsers behave, so that when you implement performance optimization, you really know what that comes from, or if you implement, I don't know, JavaScript optimization, etc. So it's really an in-depth vision of web performance, but it's free, it's really good. Yep. Thank you very much. The slides are online. Thank you.